Once again, welcome back to my YouTube channel. This is Unit 1 Physical World and Measurement for class 11th, and we are discussing its various topics. The topic which we are going to talk about today is dimensional analysis, and first of all we need to understand what the dimensions are. So the dimensions of a physical quantity are the powers to which the fundamental quantities are to be raised in order to express the physical quantity or in order to represent the physical quantity. So that means if we are having any physical quantity and we want to represent that physical quantity in terms of fundamental quantities, we will find out the number of times the fundamental quantity contained in a body. So this will determine the dimensions of a physical quantity. So let us talk about one example, and let us take the example of an area. We know the formula for area is length into breadth. And in order to find out length, we have to measure the length along one direction, and in order to calculate the breadth we have to measure it along the other direction, but in both cases we are measuring the length. So basically area contains length, that is it measures length 2 times. Therefore the dimensional formula for area is length into length, that is L square. So that means area contains a fundamental quantity length and it is taken 2 times. Therefore the dimensions for area is L square. It does not contain mass, it does not contain time, it only contains a fundamental quantity, that is length. Therefore area has a dimension L square. So now area is expressed in terms of a fundamental quantity. Similarly, if we talk about volume, in that case we have a formula length into breadth into height. Length is again a length, breadth is again another type of length, and height is the other type of length taken in the different directions. So basically volume contains 3 times length, length, length and length. Therefore length into length into length is L cube. Therefore volume contains the fundamental quantity length which is taken 3 times, therefore L3, and hence the dimension for the volume is L3. It does not contain fundamental quantity mass or a fundamental quantity time. So these are the dimensions. And then if we talk about the dimensional formula, the expression which shows that which of the fundamental quantities and with what powers enter into derived unit of physical quantity is known as dimensional formula. So when we express a physical quantity in the form of fundamental quantities raised to some power, in that case we get a dimensional formula for a physical quantity. So let us understand this concept with the help of few examples. So it is very important to determine the dimensions of different physical quantities. So first of all we will talk about the dimensional formula for the velocity, and in order to calculate the dimensional formula for velocity, we know velocity is displacement upon time. Displacement is a physical quantity which is measured in terms of length. Therefore we can take displacement as a length, and time is already a fundamental quantity which is measured in seconds. So we have no mass as a physical quantity involved in this formula. Therefore we have m0, L1 and T0 in the numerator. That is, in case of displacement we can write it as m0 because displacement represents length. Therefore m0, L1 there is one length only, and T0 there is no time involved in case of velocity or in case of displacement. And in denominator we are having a fundamental quantity time, that is m0, L0, T1. Taking T ahead, that is in the numerator, we are left with m0, L1, T minus 1. So now this expression is called the dimensional formula for velocity. Similarly, now we will calculate the dimensional formula for acceleration. We know acceleration is defined as rate of change of velocity. So therefore acceleration is equal to velocity upon time, and we have already calculated the formula for velocity, that is m0, L1, T minus 1. It is divided by the fundamental physical quantity time. For time we can write the dimensional formula as m0 l0 t1. Taking this denominator in the numerator, we are having m0 minus 0, l1 minus 0, t minus 1 minus 1. So we are having m0 L1 t minus 2 as a dimensional formula of acceleration. Now the third physical quantity for which we will calculate the dimensional formula is momentum, and the normal formula and the formula which we know for momentum is mass into velocity. For mass, the fundamental quantity mass is expressed as m1 l0 t0, and this is multiplied by velocity. For velocity, we have already determined the dimensional formula, which is m0 l1 t minus 1. So on multiplying this, we are having same basis. So in case of same basis, powers are added up. Therefore we have m1 plus 0, l1 plus 0, and t minus 1 plus 0. So we have dimensional formula for momentum as m1 l1 t minus 1. And then the other quantity is force. We know force is equal to mass into acceleration. For mass, we have dimensional formula m1 l0 t0, and for acceleration we have already calculated the dimensional formula as m0 l1 t minus 2. Therefore on multiplying, we are having for the same basis the powers are added up. Therefore we have m1 plus 0, L 0 plus 1, and T 0 plus minus 2. So we have dimensional formula m1 l1 t minus 2 for force. If we talk about the next physical quantity, that is density, the dimensional formula is mass upon volume. For mass upon volume, we can write the dimensional formula such that in numerator we have dimensional formula m1 l0 t0 divided by volume, that is m0 l3 t0. Therefore taking the denominator in the numerator, we are having the formula for density as m1 l minus 3 t0. So now we will talk about the next physical quantity, that is impulse. We know impulse is equal to force into time. As you people are new and you do not know the formula of impulse right now, so you can just memorize this formula at the moment, but with the development of your syllabus, with the growth in your syllabus, you will be learning the formula of impulse soon. So impulse has a formula force multiplied by time. For force, we are having dimensional formula m1 l1 t minus 2, and for time we are having dimensional formula m0 l0 t. And therefore on combining, we will be having dimensional formula for impulse as m1 l1 t minus 1. Then we have to calculate the dimensional formula for work, and we know work done is equal to force into displacement. For force, we are again having the dimensional formula as m1 l1 t minus 2. It is multiplied by the displacement, that is m0 l1 t0. Therefore dimensional formula for work is m1 l2 t minus 2. And then if we talk about energy, we define energy as the capacity to do work. Therefore energy has the dimensions of work, because energy is always defined in terms of work. That means we can write the dimensional formula for energy as m1 l2 t minus 2. Next we have to calculate the dimensional formula for kinetic energy. Therefore in order to find the dimensional formula for kinetic energy, we have formula half mv square. Half is a numeric value. Therefore for numeric value we do not have any dimensions, so we will not write any dimensions for half. Therefore the dimension for mass is m1 l0 t0 multiplied by dimensional formula for velocity is m0 l1 t minus 1 whole square. So we are left with a new formula, that is m1 l0 t0 multiplied by m0 l2 t minus 2. So on combining, we are having the dimensional formula as m1 l2 T minus 2. So this is the dimensional formula for the kinetic energy. Now we will calculate the dimensional formula for the potential energy. Here, when we are going to calculate the dimensional formula for kinetic potential energy, we will substitute the dimension of m, that is mass, that is m1 l0 t0, and the dimension for g, which represents the acceleration due to gravity. Because g is representing acceleration due to gravity, that means it is a kind of acceleration, and for acceleration the dimensional formula is m0 l1 t minus 2, and the dimensional formula for height is m0 l1 t0. On combining all these factors, we have dimensional formula for potential energy is m1 l2 t minus 2. From here you can see that the dimensional formula for energy, for kinetic energy and potential energy is same, that is m1 l2 t minus 2. So now we will talk about the another physical quantity, that is pressure. In case of pressure, we are having a formula force upon area. For force, we are having dimensional formula m1 l1 t minus 2. For area, we are having dimensional formula m0 l2 t0. Taking L in the numerator, we are having the dimensional formula m1 l minus 1 t minus 2. Next, we are going to determine the dimensional formula for the frequency, and frequency is equal to 1 upon time period. So time is already a fundamental physical quantity, and therefore we can write the dimensional formula for time as 1 upon m0 l0 t1. Taking in the numerator, we are having the dimensional formula for frequency as m0 l0 t minus 1. Now we will be talking about the Planck's constant. Planck's constant H is given by energy upon frequency. Again, you are not aware about this formula, but we will learn this formula later when we will be covering our syllabus. So for Planck's constant, we are having the formula as energy upon frequency. For energy, we are having the dimensions m1 l2 t minus 2, and for frequency the dimension is m0 l0 t minus 1. Taking t minus 1 in the numerator, we are having plus 1. So therefore we are having dimensional formula of Planck's constant as m1 l2 t minus 1. So this is the dimensional formula for the Planck's constant. Then for the gravitational constant, we are having the formula Fr square upon m1 into m2. For force, we are having mass m1, we are having the dimensional formula as m1 l1 t minus 2, and for r we are having a dimensional formula L and L square. Because there is r square, we will put square over L. So we are having in numerator the total formula as m1 l3 t minus 2. In the numerator, we are having two masses. So we are having the dimensional formula as m1 l0 t0 multiplied by m1 l0 t0. So in the numerator, we are having m1 l3 t minus 2 divided by m2 l0 t0, and on solving we are having m1 minus 2, that is minus 1. We are having a dimension of m as m minus 1 l3 t minus 2. So this is the dimensional formula for the gravitational constant. It is important and it can be seen in the paper, so you can expect that you can find this gravitational constant to determine the dimensional formula for the gravitational constant in your paper, in your exam. So the next quantity for which we will calculate the dimensional formula is stress. Stress is again force upon area, and we have already calculated force upon area as m1 l minus 1 and t minus 2. For strain, we are having a formula change in length upon original length, that is it is the ratio of two similar quantities, length and length. Therefore it is a dimensionless quantity, and we will write it as m0 l0 and t0. Then the other physical quantity which we are going to talk about is elasticity. Elasticity is described as stress upon strain. Stress is force upon area, and strain is dimensionless quantity. So for stress we have calculated the dimensional formula as m1 l minus 1 t minus 2, and other quantity, that is strain, is dimensionless, that is m0 l0 t0. Therefore elasticity has a dimension of stress, that is m1 l minus 1 t minus 2. Then the other physical quantity, next physical quantity is angle, which is defined as arc upon radius. Again, arc is having a dimensions of length and radius is also having the dimensions of length. Therefore it is the ratio of two similar quantities. Again, angle is a dimensionless quantity, therefore its dimensional formula is m0 l0 t0. If we are going to talk about power, it is defined as rate of doing work, that is work done upon time. For work we have calculated the dimensional formula as m1 l2 t minus 2 divided by time. So we are having the dimensional formula for power as m1 l2 t minus 3. Next we have a physical quantity which is called surface tension. It is defined as force per unit length, and for force we are having dimensional formula as m1 l1 t minus 2 divided by length. So we are left with m1 l0 t minus 2 as a dimensional formula of surface tension. The other physical quantity which we are going to talk about is surface energy. It is defined as energy upon area. So for energy we are having a dimensional formula as m1 l2 t minus 2 divided by l2, that is the dimension of area. So we have m1 l0 t minus 2 is the dimensional formula for surface energy. Next we are going to talk about angular velocity. Angular velocity is defined as angle upon time. So angle is a dimensionless quantity as we have discussed. Therefore in the numerator we are having m0 l0 t0, and in the denominator we are having m0 l0 t1. Taking it to the numerator, we are having the dimensional formula for angular velocity as m0 l0 t minus 1. The next physical quantity is angular acceleration, and it is defined as rate of change of angular velocity, that is angular velocity upon time. For angular velocity we have right now determined the formula, dimensional formula as m0 l0 t minus 1 divided by time. So therefore the dimensional formula for angular acceleration is m0 l0 t minus 2. Now the other quantity which we have to discuss is force constant, and it is defined as force upon distance. For force we are having dimensional formula m1 l1 t minus 2, and it is divided by distance, that is m0 l1 t0. Therefore we are having force constant dimensional formula for the force constant as m1 l0 t minus 2. The next physical quantity we are having is velocity gradient. It is defined as velocity upon distance. For velocity we are having dimensional formula as m0 l1 t minus 1 divided by m0 l1 t0. So we are having the dimensional formula as m0 l0 t minus 1 as a velocity gradient. And the next physical quantity is angular momentum, which is defined as linear momentum multiplied by the displacement. For linear momentum we have already calculated the formula. Linear momentum was defined as mass into velocity, and the dimensional formula for linear momentum is m1 l1 t minus 1, and it is multiplied by distance, that is m0 l1 t0. Therefore the dimensional formula for angular momentum is m1 l2 t minus 1. And the last physical quantity which we are going to define is wavelength. Wavelength is basically a distance. It has the dimensions of distance because wavelength is always measured in meter. Therefore it has dimension very simple, that is m0 l1 t0. So I hope you have understood how to find the formulas for the different physical quantities. So these physical quantities are important to know in terms of their dimensional formulas. If you have understood understood this concept, then it is important that you should practice all these physical quantities. You should practice to find out the dimensional formula of all these physical quantities thoroughly. And the homework question is there for you. That is, the first question which you can face in your examination is that name the physical quantities which share the same dimensional formula. So you have to find out which out of these physical quantities share the same dimensional formula. And the other question which you can find in your examination is name the physical quantities which are dimensionless. So you have to tell which physical quantities are dimensionless quantities. I will be waiting for your comments in the comment section. And if you have understood all this concept thoroughly, then do not forget to press like, subscribe and share button, and do press the bell icon in order to get latest notifications on my videos.